Hi Dirk, hi Andreas, welcome to the podcast.
Hi, Fabian.
Hi, Fabian.
Thanks
Really
for the invite.
appreciate you taking time for this today. Shall we start with some brief introduction? Maybe Dirk, do you want to go first?
Yeah, sure, Fabian. Yeah, thanks. Thanks for having us here. Yeah, I'm Dirk Leopold. I joined itemis about 8 years ago, and I'm in charge of a division that's called digital engineering, and part of the digital engineering is also AI. Um, Obviously, it's not just 8 years that I've been working, so I did some things before, not all automotive related, but all software related in various industries, automotive, but also telecommunication, um, media, so a broad range of experience. But I think what has been present all the time was software. And I think for the past, Andreas, when did we start with this? 6 years ago. So maybe
About
for the past 6 years, it always had a portion of AI in it. Andreas, you want to continue?
Yeah, so I'm Andreas. I've been working in the automotive industry now for almost 25 years, I guess. And I started out with the main focus of most of the time was like model-based development. Early stages, there was model-driven architecture, creating UML models and creating code out of that. So this entire left loading of the V cycle, bringing in more formal notations, and then having automated code generation was something that really fascinated me, and where we spent most of the time doing this for automotive and cyber physical systems. So that means also the aerospace industry. So I also represented a major German OEM in the AUTOSAR standard. So standardization, formalization, modeling is one of my focus points. Yeah, and quite a while ago, so 12 years ago, I started out in a research project where I had to consolidate a lot of requirements, and I thought, yeah, let's see, do I have to do this all manually, and or could we automate? And then at this point in time, I dove into natural language processing, still with programming languages like Perl and the libraries, and that was, yeah, okay, but not really, let's say, successful. And then, yeah, six years ago, more and more AI was coming up in our customers' departments, building autonomous vehicles, pedestrian detection. So we decided, okay, we need to understand what our customers are doing in terms of also helping them, and B, let's see how we can apply AI for systems engineering, basically. And then we started again out with natural language processing, and had a big growth or big ramp up in terms of topics. And as Dirk pointed out, we are also very research oriented. So I'm also heading the public funded research projects that we do. So where we get together with other companies, get some funding from the German government to investigate cool stuff. And basically, I'm in charge of building up the AI department here, and with the focus points, etc. I think we can discuss in a minute, basically, about various topics.
You should see Andreas's office. So it's basically full of remote controlled cars and sensors and cable and 3D printed extra parts, and that's all part of the journey to basically build our miniature AI controlled vehicles in the office. And I think before Corona, there were these meetings where we actually met and these races, and turned our office into a big racetrack. Fun times.
Living and breathing it. No, thank you so much both. Really appreciate the introductions. To kick things off with a little bit of a broader question, I guess today we sort of broadly speak about software-defined vehicles, set a focus on safety, security, and the role of AI and all of that. To kick things off, everyone has, or most people in the industry have heard of software-defined vehicles. Deliberately a sort of broad question: what are software-defined vehicles? Why does it matter? And how is it changing in our current environmental context?
Yeah, maybe I can start with that. So there was just recently a big discussion on one of the social medias. What does software-defined vehicle mean? Because I mean, it's a little bit of a buzzword, but obviously software-defined vehicle means that, or one of the definitions is that the major functionalities or important functionalities, if not all, are controlled and implemented through means of software. This is one of the big parts, and the implication of that is that the life cycle of that software is a little bit separated from the hardware. So it means that software is become the crucial factor of what a vehicle does, basically, and how it behaves, the function it offers to the customer. And that we are moving into a business where that software has a different life cycle, is updated much more often than the actual hardware in the car, which is probably there for 30 years, or maybe as long as the vehicle is there. And that results in totally new problems with the quick turnover in terms of development, validation, etc. And that also has some legal implications, and that's a perfect opportunity to pitch over to Dirk, because he knows all the standards that are currently applicable to security, etc., etc.
Yeah. Thanks, Andreas. I'll get to the standards in a moment. But if you think that through, if you apply principles that have been valid in the software development for decades, and you start applying them to automotive, you get some very interesting effects. As for example, that concept of minimum viable product. So when I do software development and I would like to get early feedback in order to work on the relevant features and work with that customer feedback to get the best possible improvement. That basically means I don't wait until the point in time where I think, oh, now I'm 100% ready, but I push out the software earlier. And of course, it depends on the product, whether I push it out when I have like 30% or 50% or 80%. But let's be conservative. Because it's a vehicle, so and it's expensive, so I don't want to push out, let's say, 20% software. But if I think about it, that I could really develop a vehicle and start selling it when the software is 80% done. And then I know I have another 20% that I need to develop over the next, let's say, 3 to 5 years. That's a completely different development approach compared to what we see today, where I basically have start of production at some point, but I will not add major features after start of production. But then again, you see Tesla. Tesla has been doing this for a while, yeah. So Tesla continuously delivers new functions, and I think that's the biggest difference between Tesla and many of the traditional manufacturers. They see that as a software, the car as a software problem. And for them, it's very natural to continue developing software. And for all the, say, legacy OEMs, whether this is in Europe or Japan or US, they don't see it like this. They want to deliver a perfect product, which then requires bug fixes. And the entire development process is also structured in a way that I have, let's say, 3-4 years of very intense development, and then I have a start of production, and then there's a little bit of maintenance going on afterwards. And if I change the timing now and say, okay, I wanna get out and start selling the car as early as possible, but I know I have to continue development while I already started producing that, the V model becomes tricky. Document-based process guidance and milestones becomes tricky, yeah. And now we get to the standards. So basically, I at any point in time have to make sure that my vehicle is safe and secure, and there are standards that I have to comply with. Sometimes I even need certifications for certain steps. So am I in a position today, especially traditional OEMs, to adopt my development process in a way that I can basically continuously deliver new features while at the same time still adhering to all the norms and rules and regulations and actually understand what's going on. And this is where AI becomes highly relevant, because how do I get to that transition from a document-based development process where I have 3 to 4 years of time to make everything fit, to a situation where I, worst case scenario, need to deliver weekly updates and still maintaining all the consistencies and in my development process. And that is a huge step. And of course, the hope is there that AI will be a big support in this transition process. And yes, security is a special case. Yeah, of course, the car also needs to be secure, but I think that applies to everything. That applies to quality, that applies to safety, that applies to everything that needs to be taken care of during an automotive development and production process.
Just on that last point to chip in, on the topic of cyber security and safety, what are some of the current challenges that you see amongst especially OEMs out there?
Yeah, maybe I can this time answer first. Very practical problem or practical example. So you have the development process, and then your vehicle is later on the road. And regardless of how good a job you did in the past, there will be new vulnerabilities. Yeah. So it's either hardware or software based, that there are vulnerabilities that make your vehicle potentially easier to attack than it was before. So if I hear about that vulnerability, the question is, am I affected? And how bad is it? So do I have to react or not? And to answer these questions, I basically have to have a very good understanding of what's going on in your entire V. Yeah. So vulnerability is typically software or hardware based. Let's pick the software based vulnerability. So I know that a certain software of a certain manufacturer in a certain version has a weakness. Let's say it's a Bluetooth stack. Yeah. So then I have to know, okay, do I use that Bluetooth stack? And if yes, which variants of my vehicle use that Bluetooth stack? Just because it's potentially affected doesn't mean that I really am at a higher risk that something goes wrong. So I also have to understand, where is the Bluetooth stack in my, let's say, function tree, which components use it, what kind of damages could occur if that Bluetooth stack is compromised. And these questions are answered typically in an area that's called, or in a partial process that's called TARA. So it's threat analysis and risk assessment. So basically understanding what could go wrong and how likely is it that it goes wrong. But this is not on the level of actual software. This is on a design or specification level. So on the one hand, I have concrete software that might be affected. On the other hand, I have to relate this to a more abstract process of risk analysis, which is design or specification oriented. And getting really understanding the connection between a concrete piece of software and an abstract design decision is not automatically there. There are like 5 or 6 steps in between and 3 or 4 different tools that, if you come from a document-oriented world, they don't know of each other. So there are no links. Again, AI might help because these links are basically connection predictions. Yeah, and AI is good at predicting. And maybe, Andreas, you can take over from here.
Yeah, I mean, if I may generalize from here, one of the applications of AI that the automotive companies look into in the field of systems engineering is getting a grip on the complexity. And basically it boils down, or one of the application boils down what Dirk just said. There's a huge stack of documents and tools, etc. And obviously it would be cool if I have a question about, for example, how my system could be compromised, or what happens if I change the diameter of a cable. I could just ask some version of a large language model or some AI that has been fed with all the design documents. So that's the, let's say that's the vision, or that's let's say the golden path that would be on the horizon with AI. I mean, there's a lot of things to do, example, but that it boils down, one of the application boils down to the management of complexity. For example, understanding the documents, creating conceptual links between unrelated documents, which are there in some experts' heads, but which are not explicit, and where if you come into the project and you're not an expert, you have to do a lot of working. Related to that, and maybe as an example, a lot of these tools are expert systems with specific query languages, specific modeling conventions, where you not only need to be an expert on the domain, like the harness or the let's say update mechanism, if you want to know something, but you also need to be an expert on some of the tools. And one of the current promises and directions of AI, for example, to have a really already tangible example, is replacing, let's say, point and click user interfaces with natural dialogues. Just saying, okay, let's say, okay, my assistant, what happens if this bus signal is not sent every 20 milliseconds, but every 50 milliseconds, or who is consuming this bus signal? One of the applications of AI could be to make it much easier for the engineers to get these questions answered. That would be one of the applications of AI/Gen AI in systems engineering. There's various more. We would be happy to dive in. But the complexity is key. The complexity and the speed, as Dirk said, the Chinese companies might be much faster. There's more update cycles. So I have to be really quick in finding out stuff, impact analysis of what I do with my system.
I really appreciate the context, both. Thanks so much for that. To talk a little bit more about use cases in this area from... First of all, this is not at all my area of speciality, so you might have to help me out here. But from other areas that I'm more involved in, there are sort of different levels in terms of unlocking value with AI, and there may be more and more Gen AI moving forward. And the use case you described seemed to be one that organizations could probably implement today. Maybe some are already trying that at the minute as we're speaking. If you think about it sort of as the short, medium, and long term in terms of use cases, what are some of the examples that you would recommend organizations, or maybe you've seen them, organizations implement today? What are some of the ones that might be around the corner, maybe thinking of sort of 2 to 4 years? And then what are some of the, I guess, the really blue sky in terms of some of the, I guess, super exciting stuff that might need loads more work in terms of data, technology, etc.?
So as you just pointed out, the field is huge, is very huge. So I'm not an expert in everything. For example, everything in radiated to production, actually using AI to create like a 3D model or create a specific cast for metal, that's out of my domain. So I'm more in the systems engineering. But there's a lot of stuff going on in that domain as well. But in terms of systems engineering, we already have projects, and a lot of companies are investigating things. And I would say the low-hanging fruit, or the things where the current state of AI is applicable, is, let's call it generally document analysis, like doing semantic search, understanding your documents, and for example, doing traceability. So finding links between documents. So in automotive, you need to follow automotive spice. So you have to have a traceability between your development artifacts. So that is something where we already have successfully done projects. And also, for example, one classic use case is that if you look at the tier ones, they get like specifications from OEM A, OEM B, and they have their own specification of their system. And then they would like to understand where are the similarities, where are the differences, etc. So, and that is, to my experience, a field of tasks where you can leverage AI. Why I'm saying can? Because we need to take into account, with all the excitement about AI, this is also highly dependent on the quality, volume, and type of data that you have, and that is super important. So, for example, if we have a use case of traceability and we get asked, yeah, what can we achieve with that? My standard answer is I cannot answer that without having seen your data, because for some cases the data quality is high and we can achieve good results basically in weeks, and with others you go like, yeah, look each other in the eye with the customer and say it's not going to work with that data either. You're going to have invest in improving your data. So that's one of the things. But so there is a let's say a keyword or a technical keyword. It's called retrieval augmented generation. It's basically on a high level, not only taking a large language model out of the box, but giving it additional information about your specific documents, boils then down to semantic search, similarity, and that's where you can already do a lot. And that's also where we see a lot of interests and a lot of, let's say, prototypes, investigations being done in the systems engineering field. Coming up, so another point is like, if you have textual documents, all of the projects are going to do some formal models. So there's the modeling language for systems engineering called SysML, basically, and it's for the audience that might not know it, it's maybe some of them are software people, they know UML, but it's a way of formal language with a graphical and a textual notation to describe your systems. Like very simple, a vehicle has two axles and the axles has two wheels, the wheel has a radius, etc. So, but it's a formal notation, it's not free-form text. And that is very interesting, also for validation, early evaluation, partially in simulation. And what's currently happening is that the industry is looking into using documents like requirements, document specifications from the companies and generate these models out of natural language documents, where you would right now have a team of modelers doing the actual models. That is, I think, a step. That's what's currently on the horizon. We need more publicly trained models, basically, because right now some of the models already can do a little bit, but there is no standard or huge data set of mapping a natural language to these models. Also, what's really happening is in the area of autonomous driving, basically, I would also say Gen AI is playing more and more a role in creating synthetic data. And that's a super interesting use case, because up to now I have spoken about textual documents. What we see is that, for example, for autonomous driving, you need more and more simulation to validate the car. But then the question is, how do I get enough validation data? And there, the recent advancements in generating images and movies are also super interesting, because you could have like say a video recording of a car going down a street where you test your pedestrian detection, and then you go and say to the AI, now generate a winter version of this video sequence, and you would have a new video sequence basically in no time, without having to drive down the same track 4 times per year to get different things. Long term down the road, I think what will be interesting is how much creativity, design, let's say, height the models can generate. Because right now, if we talk about the use case where we generate system models out of textual descriptions, they can do so much when the textual description is very close to what we want to generate. We are not there yet in terms of, yeah, give me the bus topology for a standard passenger vehicle, and they do everything. They haven't been trained on enough data, and there is also a little bit of a philosophical question, or it will be interesting to see the advancements of AI. Yeah, so that's a quick rundown on some of the aspects. There's probably a lot more. So as I said, it's also applicable in predictive maintenance, in production, planning, production sites, etc. It's a huge area where everyone currently looks into these tools.
Yeah, with a focus on safety and security, I think one of the challenges that we will still have to work on for a while, it's the topic of explainability. So if I decide to recall a vehicle or decide to that I have to exchange software, I have to have a reason for that. So if an AI tells me, oh, it looks like your risk has gone up, then of course I would like to know why, yeah, because I really need to understand what the dependencies are of the various aspects, so I can really make a good decision, not just a technical decision, but also a commercial decision, if this really needs to be done. And just a verbal recommendation would not be enough. Also, if I have to hand in papers to get a certification for something, I cannot reason and say, oh, it's like that because my large language model told me so. I mean, the TÜV or any other official institution here would say that's not enough. I mean, you have to really explain this, yeah. And these large language models, it is kind of a black box. So you don't know which weights result in which different end result, and even if you know the weights, you cannot explain what that means or what that translates to in real life. So if I go into domain-specific models and in SysML and in probabilities, I have to stay on that level and cannot say, okay, this was my input, and then my large language model told me the risk is high. Yeah, I think in engineering, I need transparency, and this needs to be explained. And I think in many areas, we just can't explain it yet. Yeah, so probably it's possible to break it down into smaller tasks. So the problem is then maybe isolated, and I can do some actual physical reasoning then, but explainability as a whole will still keep us or prevent us from doing everything with AI soon. And the other part that I see is if I look at Tara, so that threat analysis and risk assessment, I need data, and you don't have millions of Taras. Yeah, so that Tara process is very laborious. Yeah, and it takes you from a couple of weeks to a couple of months, depending on the size of the model. So how many models can I possibly have? Yeah, and even large OEMs, they maybe have a few hundred models. So what kind of training results can I expect from a couple of hundreds models? And the depth and the width of these Taras, they also vary. Yeah, and then the design level Taras and specification level Taras, Taras of complex elements and less complex elements. Training data is wild. Yeah, so it is a full spectrum, and honestly, I haven't tried what happens if I start training models with let's say 100 Taras. Will that be anywhere close near training data volume that's helpful? Yeah. So Andreas said there are many areas where you have low-hanging fruits and you can apply it already today, but I think there are certain areas that we need to do a lot of research on to really get a sense of how useful it is.
I really appreciate your perspectives. Just building on that last point, there seem to have been over the past year and a half, loads of proof of concepts that didn't really scale. You mentioned, okay, data considerations are really critical, especially in your area. What are some of the other considerations to get from an idea to a successful POC to a solution that actually scales, which is usually, I guess, where the value sits in our globally operating organizations?
The scaling part, and I think Andreas can add a lot more to that, sometimes also comes from productizing it. So even if I have good data and I do a POC and I see that I actually can get some value out of it, the POC is very laborious and with a lot of manual work. And if I identified a scenario that would work for me and I know how to train the model, training the model is only a fraction of the overall work. So collecting the data and preparing the data, standardizing it, have all the data transformations in the background and automating the entire process is something that companies often underestimate. And the people that they hire, they are often specialized in that training the model part, and they are not necessarily the experts for everything that happens before and after. Yeah, and this is where you have a lot of normal IT work that is overwhelming for some machine learning experts. Yeah, and I think that that's also why the team that Andreas has is not just people with machine learning training knowledge, but also regular processing and IT know-how and skills that you basically have to build up over time.
Yeah, I would say the major challenges that we see in the projects that we do are less in terms of deploying stuff. So it's, for example, we have scenarios where the customer has a contract with Microsoft, and then it's very easy to set something up with the OpenAI offering of Azure, or they have a strong VM and we can deploy models locally. It's the entire workflow documentation, etc., on how is this supposed to work, how do we leverage the stuff, and also how do we get the training or the data, how do we get access to the data? Because there might be a little bit of expectation, how do we call it, impedance, because everyone is playing with ChatGPT and saying, okay, tell me everything about my next holiday location, and that's working super good. But these large language models haven't seen, or hopefully haven't seen, your company data that you have behind firewalls. So they don't know your stuff out of the box. And then getting this available, cleaned up, etc., is part of the process, which can amount to more work than the let's say simple deployment of the frameworks, the scripts, the data ingestion, etc., where there are a lot of building blocks out there. So that is a key factor. So you need to know basically that there is some effort coming up to you in managing the data, and getting a data strategy, seeing data not only as a side product of what you do to need to build the vehicle, but also a crucial artifact that you want to manage and leverage and exploit as a company. I think that's one of the philosophy shifts or mindset shifts that's there. It's not, data is not only auxiliary as a side product to the final vehicle or whatever you build. It's a crucial artifact for improving your processes, and that's something that companies are going to have to learn. And interestingly enough, that's why, just as a side comment, I see all the activities around Dataspaces. This would break this talk basically, but there's a lot of activities right now where I see also a change in attitudes where companies cooperate more and more and exchanging data trustworthy. This is even exceeding the boundaries of the organization, but you need to clean up your data management in the company basically, and then we can go the next step. But that would be one of the crucial factors where I think that's a really important make or break factor.
Especially the engineering domain, and you sort of alluded to this over the past half an hour, is very complex, requires system engineering. And what I've seen from in one of the only projects in the engineering domain I've done is that there are lots of silos, lots of teams that sometimes not talk to each other, yet have loads of dependencies on each other as it relates to dimensions, weights, and some of the other things you refer to, which leads me sort of to a challenge with some of these Gen AI initiatives in other business areas I've observed, which is the topic of governance. So what would be your recommendations to govern Gen AI initiatives in the engineering domain to make sure that some of these potential challenges that you alluded to could be mitigated?
There I would actually suggest that companies look into concepts like data mesh, basically. So that goes again into this entire data space philosophy, but it boils down to what you said, a lot of silos, and going to actually create a mindset where you go like, the data that you produce is valuable to the company, and we want you to share it, basically. So making sharing data a positive thing in the company, that's one of the aspects, because you need to live that. I think a lot of the things that are ordered top down, saying we need to do Gen AI, and now you have to do data for that and that use case. And that is obviously the motivation, but providing the data itself must become something of value, and then you can leverage it for AI, basically. And that's what I would suggest. And this ties into what I tried to say before. So making not only the end product or what you contributed to the end product part of your goal as an individual, as a team, but also providing the data, because then you can leverage it. And there's a huge topic, or let's say a huge community out there alone for managing the data. And always coming back to that. I'm personally really more interested in what the AI does, basically, and all these cool technologies of what's happening, transformers, new architectures, etc. But it doesn't work on the data, without the data. I mean, you can build the newest, coolest engine if you don't have no fuel. You will never have fun with it. And that's one of the really things to consider. It's not only about deploying an LLM on your site and everyone will be happy. It's also providing the data. And that's where you might expect a lot of grunt work.
Yeah, if you go back to the process and method level, so not just the data, let's say we are in a position where all departments agreed it's good to share data. What we often find critical is also a couple of data management principles. And there's one principle that's very helpful, is to have a single source of truth. Because if I look at requirements, for example, so also in the Tara process, I work with requirements. So what are these requirements? Are these copies of the original requirements, or are these additional requirements, or are these different requirements? And especially if I have a dynamic process and I have to and changing data is normal. I have to know what are the places where I have to change the data so everyone can be sure that everyone talks about the same data. So if I have specification information in documents, and then I have specification information in a PowerPoint, and then maybe some other department has specification information in Enterprise Architect, and then you have changes in some departments, and then these changes are not reflected in the specification of the other department, it all falls apart. Yeah, it all falls apart. And the more dynamic the process gets, the more stringent I have to be about what is the truth. Yeah, so we all agreed we're going to share it, but then people start making copies, and then I change something, but it's not changed in the copy. But the copy is part of the work product of someone else, who then makes decisions based on this then outdated data. Yeah, and that's not just true for AI, but that's in general true. If I have to understand dependencies of a complex system, I have to know what is the truth. Yeah, and then I'm not on an AI level, not even on a tool level, but that's then a process and method level, where I have to agree on certain, I don't know, rules. Yeah, and that's also political, because then one department is in charge of the truth and the other department is not in charge of the truth anymore, so they have to basically take whatever truth is provided by someone else.
Thanks so much, Andreas and Dirk. It marks the end of our conversation. Really appreciate the perspectives you shared today, and that you took time out of your busy schedules for this. And yeah, no, couldn't thank you more.
Thanks for having us.
The invitation. Yeah. So, yeah.